And why short circuit and open circuit cannot be provided is because there will be lot of interconnections between the systems, and those interconnections will be in the order of operating wavelength. So in that case, my generating open circuit or short circuit in my circuit will actually tend to change the circuit behavior. I don't want to take risk by making a proper stable system unstable, so I don't want to do that. So I measure the parameters in a different way. That is called as S parameters. So S parameters, they have this beautiful property. So they are not going to depend on voltage or current, because at high frequency I cannot measure voltage or current. I'm going to measure everything in terms of power only. Okay, so you know V into I equal to power, right? So I'm going to measure everything in terms of power, and that too I'm going to use two types of power. One is incident power, other one is reflected power or scattered power. So if P1 is incident power at port 1, PR is going to be reflected power at port 1. If port 1 is perfectly matched, how much ever power you give will go inside the network. But if port 1 is not perfectly matched, if you give P1, PR will be reflected back. So effectively, P1 minus PR will be entering your network. Please be very clear on that. So scattering parameters are based on power relations and not on voltage or current. That too, we have incident power and reflected power. Okay, so see here, it should be clear here. So same two-port network. See, I am using Z naught everywhere because I'm perfectly matching the network, and EI1 is the incident voltage, ER1 is the reflected voltage at port 1. EI2 is the incident voltage at port 2, ER2 is the reflected voltage at port 2. You may ask a question. I was telling everything in terms of power. Why I'm suddenly bringing voltage here? Power is finally got by multiplying V and I. So we analysis, we'll do everything with respect to voltage and current. Finally, we'll convert everything into power. So you remember in transmission line, whenever you see Z naught, it means perfectly matched or it is perfect termination. And this is going to be the uh, S parameter equation. B1 equal to S11A1 plus S12A2, B2 equal to S21A1 plus S22A2, and A1, A2, B1, B2 relations are given here. And remember, all the B's are going to be all the B's are going to be the reflected values, and A's are going to be the incident values. So A1 is incident, B1 is reflected. A2 is incident, B1 is got. A1 is incident, B2 is got. A2 is incident, B2 is reflected. So remember, all the A's are incident. A1 means the input is going to be, first port is A1. So the A1 will come somewhere here. And second port is A2. So A2 will come somewhere here. And B1 is the reflected power, so it will be in the opposite direction. So A1 and B1 will be in the opposite direction. A2 and B2 will be in the opposite direction. Okay, so remember, all the A's are input and all the B's are going to be the reflected parameters. And we are dividing by square root of Z naught to convert them in terms of equivalent voltage. You know, power is going to be V square by R. And this A, B, A1, A2, B1, B2, they represent square of power. So if I want power, I should take square root. So square root of E square by Z naught will be E by root of Z naught. That is why we have square root of Z naught coming in all the expression for A1, A2, B1 and B2.